Hello everyone, I'm Akash Joshi. I'm the Operations Research Guru, and today we're going to be talking about Gaussian elimination, one of the most famous ways to solve a system of equations. This is used with matrices, which are commonly used with artificial intelligence development and operations research. Gaussian elimination is a key skill you'll need if you're planning to take the next step in your operations research career in understanding optimization algorithms. Okay, let's get into it. All right, so let's start with this. We have a system of equations. This can be represented as a matrix, but for now, we'll represent it as just a normal system. Okay, so the first equation is this, the second equation is this, and the third equation is this. Okay, so the first step is something called forward elimination. This is the first step in Gaussian elimination. What we're going to do is we're going to eliminate the first variable in the first column. In this case, it would be x. And after we eliminate the column 1 variable, we'd eliminate the column 2 variable, and then we'll eliminate the column 3 variable, and so on, until we have only one variable left and we have an answer that says like z equals something or something like that. All right, so how do we eliminate the variables? Simple. We just use elimination, which is something you must learn in middle school or high school in algebra. And yeah, so how would we do that? So if you notice, we want to eliminate x, which is our first variable. We want to use the first two equations. We want to eliminate x from these two equations. So first we need to eliminate this x, and then we'll eliminate this x. Let's focus on this for now. First, we will multiply the first equation by 2 and the second equation by 3. That way, they are both 6x. And then what we will do is we will do the second equation minus the first equation. So once you get that, you would get 16y minus 19z is equal to 121. The way you would do that is this would become 6x, and this would also become 6x. So 6x minus 6x is just 0. This would be 12y, and this would be negative 4y. And if you do 12y minus negative 4y, you would get 16y. And then over here, this would be negative 9z minus minus 10z, and that would give you negative 19z. And then over here, you get a number, and you get a number here, and then you get 121. Um, I'm not going to multiply that out. I multiplied it out a long time ago, so yeah. Okay, so now that we have this equation eliminated with x, we need to eliminate the next equation's x, this 5x here. We would do it the same way. We would use this equation, multiply this one by 5, and we would multiply this one by 3 in order to get 15x here and 15x here. And then we would subtract this equation from this equation. And once you do that, you get negative 8y minus 46z equals 106. Okay. That is our next that is the end of the first part of step 1. The second part of step 1 is to eliminate y. Okay, how do we do that? Okay, this is pretty simple. We would just multiply negative 8, this equation right here, we would multiply it by 2. That way we would get negative 16y and positive 16y here, and we add them and they cancel out. So in this step, we're eliminating the column 2 variable. Okay, so once we do that, we would get this right here. If you notice, this would be negative 16y, and then we would add it to 16y. That would cancel out. This would become negative 92z. We would subtract that negative 19z, so it would be negative 92z minus 19z, which would be negative 111z. This would be 212 plus 121, which would be 330. So now that we have just z in our third equation, we can simplify it to z equals negative 3. Because if you plug in z equals negative 3 into over here, you would get negative 111 times negative 3, which is just 333. And yeah, this is simple algebra. So if you don't know how to solve that, I would recommend checking out some algebra videos. Okay, now that we have solved for our first variable, we are good to move on to step 2, which is called backward substitution. And this is basically exactly what it sounds like. Now that we have z equals negative 3, we are going to substitute it backwards into the equation above it. So this would become 16y plus 57 is equal to 121, and then we would solve for y. And then now that we have y and z, we would substitute them into the equation above it and solve for x. And if there were more equations, we would keep going up. So yeah. Okay. Now, once you do that, you will get this right here, x equals 2, y equals 4, and z equals -3. And you might be asking, what are these pivots doing here? What is a pivot? So a pivot is just simply the coefficient, the leading coefficient of the equation. So over here, it would be 3, 16, and 1. These are the leading coefficients of each of the equations that you have. You might be asking, what is the point of these pivots? Well, these pivots come into play later, so just keep them in mind for now. Okay, so now let's talk about displaying these system of equations as a matrix. Typically in operations research, artificial intelligence, and programming, we are going to use matrices instead of systems of equations because we can do more things with matrices, and programming languages tend to enjoy matrices more than systems of equations. So the first system equation, the problem, is shown right here. You have the coefficients of each of the terms, and they are equal to each of the numbers right here. Then we are going to complete step 1 and show that we're not going to complete step 1, sorry. We're going to complete the first part of step 1, and we are going to eliminate the column 1 variable, make them 0, and perform operations to get our new numbers in the bottom 2 rows. And then we're going to complete the second part of step 2, which is eliminating that variable in the equation 3, the leading variable in equation 3. We're going to make that 0 and perform the operations that needed to be performed in order to get these numbers over here. Then we are simply simplifying them, make -111 just 1, and make 333 -3. We are dividing 333 by -111, and that is the end of step 1. Next, we'll move on to step 2 in the matrices, and that is backwards substitution. So now that we have z equals -3 down here, we are going to plug it back in over here, and we would move that term that we get after we multiply it out to the right-hand side, and we would get a 0 here, and it would be 16y is equal to 64. And then we would simplify it and get 1 and 4, y is equal to 4. And then what we would do is that we would substitute y equals 4 and z equals -3 into here, and we would move these terms to the right-hand side again, and that would give us 2. And yeah, that means x is equal to 2. So we have our solution. X equals 2, y equals 4, and z equals -3. X equals 2, y equals 4, and z equals -3. Okay, so something to keep in mind. This process only works for non-singular systems. Non-singular means that there's only one solution. And there is further Gaussian elimination theory, and I will explain that in a later video, so stay tuned for part 2. My next video will explain how to solve singular systems with Gaussian elimination. And if a 0 appears in a pivot position, this can become problematic, and we would need further theory. I would need to teach you more about Gaussian elimination to solve that system equation if a 0 appears in a pivot position. Okay, thank you for watching. I'm Akash Joshi. I'm the operations research guru. Goodbye.